Hello students, good evening everyone. I hope all are doing well. Welcome to Infinity Learn by Sri Chaitanya. This is me Surya, your chemistry faculty from Infinity Learn. And I hope I am perfectly audible and visible. So those who are watching the particular session, just mark your attendance here. So in the last 3 classes we have discussed about the new chapter, classification of elements and periodicity and property. The first chapter, first class we have discussed about the introduction part of the periodic classification, right? How to classify the elements. Hi Arush, good evening, welcome to the session. So in the first class we have discussed about the basic introduction about the periodic table, right? Basic introduction about the classification of elements. We have seen different classification starting from Dobrynin's triad, Newland's law of octaves, then the, Moseley's periodic table and Mendeley's periodic table, right? The second class we have discussed about the modern introduction to the modern periodic table. We have seen how to predict the position of a periodic table, right? Position of an element in the periodic table, right? I hope you guys watched the recorded session for those classes. And the last session we have discussed about the periodicity and properties, right? We have seen the atomic radii, metallic character as well as the non-metallic character. So today in this particular session we are going to discuss the another properties, their trend in groups and period. That's about the ionization enthalpy, right? Ionization enthalpy, electron gain enthalpy and the electron negativity. So by this class we are going to cover all the properties, all the properties, periodic trends of properties in detail. Fine? Okay, I believe you have watched the recorded session for the last 2 classes. Then only we will get an idea about the ionization enthalpy here. So we will start our next property, that is the ionization enthalpy. So what do you mean by the ionization enthalpy? It is the energy, right? It is an energy. For example, if you are taking any of the element, any of the single atom, if you are adding more electrons to the atom, we will be required a minimum energy, right? So we can define the ionization enthalpy as it is the minimum amount of energy required to remove an electron from an isolated gaseous atom. So what do you mean by the isolated? Isolated, it will be single, right? There will not be any bond between the atoms. So single atom is known as the isolated atom. So isolated gaseous atom. So they will require an energy. That energy is known as the ionization energy. So if you are representing a metal, right, metal or the element represented by M in gas, it will be gaseous isolated atom, right? So if you are adding the energy of ionization energy or ionization enthalpy, it will be forming M plus ion plus electron, because they are losing the electron, right? It is the removal of electron. So the electron is removed from here by forming M plus ion. So this is the representation of ionization energy. Clear? Yes, I stands for ionization energy or the ionization enthalpy. Hi Durgeshwar, good evening. Now in general, if you are taking any of the elements, we need an extra energy, right? We are giving the energy, so it will be always positive, right? It will be always positive. So the energy is always required to remove electrons from an atom, and hence the delta H value or the ionization enthalpy value will be always positive. Clear? Is that clear? So this is the basic introduction about the ionization enthalpy. What do you mean by the ionization enthalpy? Okay, I have already written here, right? Isolated atom, it will be single atom. If you are taking a single atom, okay, single atom that is free from any other bonds, that a single atom is known as the isolated atom. So if you know about the isolated condition, right, it will be a single observation. So isolated, it is different from other atoms, which is free from the other atoms. Okay, delta H generally represents for the energy representation. So you will be discussing detail in the higher classes about in the case of grade 11 or something. You will be discussing about the thermodynamic term. So there will be, we are representing delta H value as the enthalpy term. Clear? So you can just put here as ionization enthalpy or IE value here. Now in the case of ionization enthalpy, we will be dividing this ionization enthalpy into first ionization enthalpy and the second ionization enthalpy. So what do you mean by the first ionization enthalpy? So as we already know how to write down the electronic configuration, right? Subshell electronic configuration. For example, if I am taking any element, right? If I am taking any element, if I am removing the last electron, right? If I am removing the last electron from an isolated gaseous atom, that particular energy required will be the first ionization enthalpy or represented by IE1, right? First ionization enthalpy. If I am taking an element, if I am losing the last electron from the particular isolated gaseous atom, I will be requiring some energy, right? Those energy is known as the first ionization enthalpy. Clear? And there is one more term for this first ionization enthalpy. This is the ionization potential, right? Ionization potential. So it is denoted by the letter IE1. Clear? So it will be forming the unipositive ions. For example, if you are taking Na here, right? If you are taking Na here, while losing the last electron from the sodium atom, it will be forming Na plus ion, right? So that amount of energy required is known as the first ionization enthalpy. Now what do you mean by the second ionization enthalpy? Second ionization enthalpy. So first time we have just removed the last electron from the particular element, right? So there will be getting a one ionization enthalpy or the first ionization enthalpy. Again I need to remove the other last electron from the same element. I need to again add some energy, right? That particular energy is known as the second ionization enthalpy. Clear? Is there any doubt? Or in words we can say that it is the energy required to remove the electron from an isolated unipositive gaseous ion, right? From an isolated gaseous atom we are providing the unipositive ion, right? This is a unipositive ion, one positive charge, that is the unipositive ion. From the unipositive charge ion we will be removing one more electron. So we will be getting M2 plus ion plus one electron. This is represented by IE2 or stands for second ionization enthalpy. Clear? So this will be the di-positive ion. It is not deposit, it is di-positive ion. Two positive charges present there, so it is a di-positive ion. Now we need to check how this ionization enthalpy or ionization potential is related to the atomic radii, right? Atomic radii. So I think in the third class about the periodic properties, we have seen what is the trend in atomic radii, right? If you are taking the atomic radii, what is the trend in atomic radii in the case of group? If you are moving top to bottom in a group. Size increases or decreases? It will be increases, right? So the ionization enthalpy is always inversely proportional to atomic radii. If I am taking directly proportional 1 by atomic radii, which means that as the size increases or the radii increases, ionization enthalpy decreases and vice versa. Clear? Is the point is clear? Then only we will get an idea about what is the trend of ionization enthalpy in a period as well as a group. So the reason is given here as the number of shells increases, right? As we already know, there will be K, L, M, N shell, right? As the number of shells increases, which means size increases, the distance between outer electron and the nucleus will be higher, right? It will be increases. So that the attractive force between the last electron and the nucleus will be decreases here. So that's why ionization enthalpy is less here, right? Is that clear? Now, there is no any particular reactions for these chapter. We need to just get an idea about the periodic table. What is the importance of periodic table? What are the different elements in the periodic table? Try to write down the electronic configuration. Try to find out the period, block and group of those particular element in the periodic table. And the complete reactions we have studied in the first chapter, chemical reactions and equations. Durgesha, which point I want to repeat this thing, right? So how this ionization enthalpy is inversely proportional to atomic radii. As we are saying that atomic radii increases, right? Which means number of shells increases. Number of shells increases, right? So if the number of shells or size increases, if I am taking the outer electron, right? If I am taking the outer electron, there will be very less attraction between the nucleus and the outer electron, right? Nucleus and the outer electron. So very less attraction means we can easily remove the last electron, right? So we need only very less energy, which means that as the size increases, ionization potential or ionization enthalpy decreases. Clear? Is the point is clear? Okay, fine. Now you can say what will be the trend of this ionization enthalpy from top to bottom in a group according to size. So what is happening to the size in the case of group if you are moving from top to bottom in a group? What is the general trend of size? Size increases or decreases? Clear? As we are moving from top to bottom in a group, general size increases. Atomic radii or size increases. So size and ionization potential or ionization energy are inversely proportional, right? So if you are moving top to bottom in a group, size increases means ionization enthalpy decreases. Clear? That is why it is given here. In a group from top to bottom, the ionization energy gradually decreases. So if you are considering the first group element, right, hydrogen, lithium, sodium, potassium and rubidium, if you are considering the values here, you can say that different units are given here, electron volt per atom or kilojoule per mole inverse. This is our major unit used in common. So what you are observing here, this ionization potential is gradually decreases from top to bottom in a group, right? From the data we can say that ionization potential decreases. So from the diagram we can say that this is the lithium, then sodium, then potassium, rubidium and cesium, right? So this is the data. From this data we can draw the plot for this graph. Delta H versus atomic number. Clear? Is there any doubt? Now what will be the trend of this ionization potential in a period if you are moving from left to right in a period? Just concentrate with the thing of atomic radii. What is happening with the atomic radii in the case of left to right in a period? Then connect it with the ionization energy or the ionization potential. So what is happening with the atomic radii when we are moving from left to right in a period? Left to right in a period. What is the general trend of atomic size? Arush, did you watch the previous session about the atomic size or atomic radii? Okay, if not, try to watch those sessions, then you will get an idea about the atomic size or atomic radii. So I will just give a brief idea about that. If you are asking about the size from left to right in a period, what is happening to the size? Size decreases, right? Left to right in a period, size decreases. So that ionization energy, which is inversely proportional, so ionization energy gradually increases. And the reason for that increased value of ionization energy is given that as we move across the period, right? As we move across the period. For example, if I am taking the as we move from lithium to beryllium to boron to carbon, right? This is the same period. So what is happening to the size? Size decreases, right? So the atomic number of the elements increases because it is 3, 4, 5 and 6. And the nuclear charge increases. Atomic number increases means nuclear charge increases. But the electrons are added to the same shell because it is the second period element, right? Because it is a second period element. So the distance between the nucleus and the outer electron decreases. Distance between the nucleus and the outer electron decreases, which means that there will be strong attraction. So if you want to remove those electrons from the outer electron, outer shell, we need to require more energy, right? We need to require more energy. So that energy is known as the ionization energy here. Clear? That variation is totally different from maths and chemistry. Here it is means just what is happening in the period, what is happening to the ionization energy when you are moving from top to bottom in a group as well as the left to right in a period. Is there any doubt? So from the diagram you can say that there will be the variation, there will be a change of ionization enthalpy for the different elements, right? Different elements in the period, right? Because it is lithium, sodium, potassium, these are the group element. And clear? For CBSE batch, I have already completed the syllabus. So this is the advanced level. If you are focusing on the competitive exam, this chapter is very important, periodic classification of elements. So here some anomalous properties are given here. For example, if you are taking beryllium and boron, right? Beryllium and boron. After beryllium, it is coming boron. So we are expecting in the case of beryllium and boron, there will be huge difference in the ionization enthalpy, right? But the difference is that beryllium, ionization enthalpy of beryllium is more than that of the boron. Clear? In general, we will be expecting boron will be having more ionization enthalpy than the beryllium. But the actual practice, it is said that beryllium is greater than that of, ionization enthalpy of beryllium is greater than that of boron. Why? Because of this stable electronic configuration. So I hope you have idea about to write down the electronic configuration of elements, right? So in the case of beryllium, beryllium is having the atomic number 4. So if you write down the subshell electronic configuration, it will be 1s2, 2s2, right? Which means it is completely filled. In an s orbital, there will be have 2 electrons. Maximum capability of filling the electrons will be 2 here. So it is completely filled. If you are having any completely filled or half filled orbital, their stability will be maximum, right? Their stability will be maximum. So beryllium atom contains completely filled outer orbital, so they have greater stability, hence energy required for to remove that electron will be very high. Clear? Is this point is clear? Beryllium and the boron. This is the anomalous pair. If it is clear, you will get an idea about the nitrogen and oxygen, right? Nitrogen and oxygen. So in general, nitrogen and oxygen will be having, we are expecting oxygen will be having the higher ionization enthalpy than the nitrogen. But in actual practice, nitrogen is greater than, ionization energy of nitrogen is greater than the oxygen. Why? Because of their stability of electronic configuration, right? If you write down the electronic configuration of nitrogen, nitrogen is having the atomic number 7, so it will be 1s2, 2s2, 2p3. So in the case of p orbital, their maximum capability is 6 electrons. So here it is 3 electrons, which means it is half filled, right? Again, if you are having half filled or full filled orbital, they will be having higher stability, right? So if they are having more stability or higher stability, we need to require more energy to remove those electrons. Clear? Is there any doubt in this point? That's why when we are drawing the diagram between delta H value or the ionization enthalpy value versus atomic number, there will be huge difference in between beryllium and boron, right? So in general it will be a straight line, but beryllium is having more value of 899, and similarly in the case of nitrogen it is 1402, right, as compared to oxygen. So this is the anomalous behavior for the ionization enthalpy. I hope you understand. Now we are moving to our next property, that is the electron gain enthalpy. I think in the CBSE syllabus it is only 4 chapters: chemical reactions and equation, acid, base and salts, metals and non-metals, and last one carbon and its compounds. So what do you mean by the electron gain enthalpy? From the name itself, we are gaining the electron, right? We are gaining the electron. So the amount of energy required to gain the electron is known as the electron gain enthalpy, represented by delta HEG. Delta H commonly represents the enthalpy, or EG stands for the electron gain enthalpy. Clear? So just opposed to the ionization enthalpy, we are just adding one electron to the neutral isolated gaseous atom, right? Neutral isolated gaseous atom. So in general, the unit of electron gain enthalpy is kilojoule per mole or the kilocalorie per mole. So in general, again, in the case of electron gain enthalpy also, it is again classified into 2 types. One is negative electron gain enthalpy and another one is positive electron gain enthalpy. So from this sign itself, we can identify that if you are releasing the energy, right, if you are losing the energy, it will be taken as negative electron gain enthalpy, right, negative electron gain enthalpy. So generally, if you are taking the halogen compounds, so what do you mean by the halogen compounds? There will not be any particular name for the ionization enthalpy as electron loss enthalpy, so you can just memorize like that. Whenever you are losing electron, it will be connected with the ionization enthalpy. If you are gaining the electron, it will be electron gain enthalpy. So halogen is group 17 elements, right? Fluorine, chlorine, bromine, iodine and astatine, right? So generally fluorine to iodine are the halogen elements. So they are having the negative electron gain enthalpy. They are having the negative electron gain enthalpy. And in the opposite case, if you are just giving the energy, right? So when an atom is not ready, reluctant to for the addition of a new electron, we will be supplying more energy to that, so that they will be getting a positive electron gain enthalpy, positive electron gain enthalpy. In general, all the noble gases like helium, neon, argon, krypton, and the alkaline earth metals. Alkaline earth metals means group 2 elements. We have already discussed in our introduction part of the periodic table, right? Group 2 element. These are the alkaline earth metals. So alkaline earth metals as well as the noble gases show positive delta HEG, or the electron gain enthalpy. Clear? So this is the representation. If you are taking an isolated gaseous atom, if you are gaining 1 electron, it will be forming X minus union negative ion, right? So this delta H value is known as the delta H electron gain, or electron gain enthalpy. Now we need to check what is the trend of these particular electron gain enthalpy in a group as well as the period. So what do you think, whether it is increasing or decreasing in a group? Here also you can just connect with the atomic size, right? You can also connect with the atomic size. So atomic size is increases from top to bottom in a group, right? So electron gain enthalpy gradually decreases, or you can say that delta H Eg is inversely proportional to atomic radii. Clear? So top to bottom in a group, what is happening to the size? Size increases, right? So as the size increases, nuclear charge increases, so that the attraction of the added electron by the nucleus decreases, right? So electron gain enthalpy also decreases. I know that it will be very hard to memorize those things. So whenever you have idea about the atomic size, you will be getting an idea about the general trend of all the properties. Clear? Now we need to talk about the variation in period, right? Generally in the case of period, left to right in a period, what is happening to the size? Size decreases. So size is again inversely proportional to the delta H Eg or electron gain enthalpy. So in the case of period, if you are moving from left to right, electron gain enthalpy gradually increases, right? The same reason is given here. Once moving across the period, what is happening to the atomic number? Atomic number increases, right? So the nuclear charge also increases, and because of that, the attraction, right? The attraction between the added electron and the nucleus increases, so that electron gain enthalpy also increases. Clear? So if you are focusing about the ionization enthalpy as well as the electron gain enthalpy, there will be decreases, it will be decreases from top to bottom in a group, as well as it will be increases from left to right in a period. Same trend, which is inversely proportional to the atomic size or radii. So these are the data or the value for the electron gain enthalpy in the case of different groups elements. So if you are focusing here, you can say that what is happening from left to right in a period, it will be moving from negative to positive, right? So we can say that the positive electron gain enthalpy is for the noble gases. And also you can say that beryllium and magnesium as the alkaline earth elements, right? Alkaline earth metals. So group 2 elements also shows positive electron gain enthalpy, and the remaining others are having the negative electron gain enthalpy. Clear? Ritik, I think this is not in your regular board examination. In that board examination, there will be only 4 chapters we have already completed, and this is the advanced level. Now we are moving to our last property, that is the electronegativity. So what do you mean by the electronegativity? So as we already know, there will be different bonds, right? Ionic bonds as well as the covalent bond. So these covalent bonds are formed by the sharing of electrons, right? Sharing of electrons. So for example, if you are taking any of the covalently bonded compounds, there will be difference in their electronegativity, right? Difference in their electronegativity. So it is a measure of relative tendency of an atom to attract the shared pair of electrons, towards itself in a covalent bond, right? That is known as the electronegativity. So from the electronegativity difference, we can identify whether the bond is more polarized, more electronegativity or not. And electronegativity is not a property of an isolated atom, right? This is not a property of a single atom, because whenever they have any covalent bond, whenever they have a connection with the bond, right, covalent bond, there will be the presence of electronegativity. This is not a property of an isolated atom. But whenever we are discussing about the ionization enthalpy or electrogain enthalpy, it is a property of isolated atom, right? Isolated gaseous atom. Now we need to focus on the variation in a group as well as period. So whenever you are discussing about any of the property, okay, if you are saying gaining or loss of electron, there will be the ionic bond formation, right? But in the case of electronegativity, it will be asking about the covalent bonds only. Covalent bonds means there will be the sharing of electrons. So if they are having the sharing of electrons, there will be the tendency to attract, right? Tendency to attract the atoms towards itself. That property is known as the electronegativity. We cannot predict by the gain of electron or loss of electron. So we can just predict the gain of electron or loss of electron by using ionization enthalpy or the electron gain enthalpy. Is that clear, Arush? So what will be the trend of electron negativity in a group? Similarly, we can just connect with the atomic radii, right? We can just connect with the atomic radii. So what is happening with the atomic radii when we are moving from top to bottom in a group? Yes, it is specifically about the covalent compounds. So when you are moving the group, right, atomic radii will be increases. So these atomic radii and electronegativity are again inversely proportional. So electronegativity will be decreases in a top to bottom in a group. Top to bottom in a group, electronegativity decreases. Clear? Then what about the case of period? If you are moving from left to right in a period, what is happening to the atomic radii? It will be decreases, right? So these atomic radii is inversely proportional to electronegativity. Electronegativity also increases from left to right in a period. So this is the general trend of electronegativity along a group as well as period. Is there any doubt? Arush, what do you mean by a period? Is it a column or row? In the first part we have discussed that there will be 7 horizontal rows, right? Those horizontal rows are known as the periods. So how we can predict the top to bottom in a row? Okay, I hope you understand. So what will be the answer for this question? Which set of elements shows positive electron gain enthalpy? Some set of elements are given here. Option A, helium, nitrogen and oxygen, and option B, neon, nitrogen and chlorine. Option C, oxygen, chlorine and fluorine, and the last one, nitrogen, helium and neon. Yes, option D is our correct answer, right? Option D is our correct answer. As we already know, in the case of helium and neon, they are the noble gases. They are having the positive electron gain enthalpy. So if you are focusing about the nitrogen also, they are having the positive electron gain enthalpy. So the set of elements having the positive electron gain enthalpy is nitrogen, helium and neon, which means option D will be the correct answer. Here is our next question. In general, the property or magnitude only that shows an opposite trend in comparison to other properties across a period. So these are some important properties we have discussed in the classification of elements of the periodicity property. We have seen the ionization enthalpy trend, electronegativity trend, electron gain enthalpy trend and the atomic radius. You need to identify You need to identify the property that shows an opposite trend in comparison to other properties across a period. I hope you understand the question. Arish, give me at least one answer. C or D? Yes, option D, right? Option D is the correct answer. So this is a complete summary of the periodic properties of elements, right? So we have seen the ionization enthalpy, right? Ionization enthalpy. So if you are asking about the ionization enthalpy, from left to right in a period, ionization enthalpy increases and electron gain enthalpy also increases. Electronegativity also increases, but the only one factor which is decreases along a period is atomic radii, right? So option D will be our correct answer along a period. Similarly, if you are asking about the group also, this will be the only one trend which is opposed to the other general trend, right? So if you are focusing the groups here, what is happening to the electronegativity? Electronegativity increases, electron ionization enthalpy also increases, and electron gain enthalpy also increases, but atomic radii decreases, right? Clear? Okay, in the case of periodic table, you must have idea about how to write down the electronic configuration of elements. From that, you need to identify the period, block as well as the group of those elements. That's the main important point you have to keep in mind about the case of periodic table. Then only you will get an idea about the complete idea about the periodic properties of the elements, right? And it will be easy for you to get idea in the higher class. I mean, in the grade 11 also you are going to discuss the same chapter, classification of elements and periodicity in properties. This will be the complete summary of the periodic properties of the elements. So as you can see over here, we have discussed the first thing we have discussed about the atomic radii, right? Atomic radii. So what is happening in the atomic radii? If you are moving from top to bottom in a group, it is increases, right? Atomic radii increases from top to bottom in a group, while electronegativity, electron gain enthalpy and ionization enthalpy decreases, right? Decreases. Then what is happening in the period? In the case of period, the atomic, if you are moving from left to right in a period, electron gain enthalpy increases, ionization enthalpy increases, and electron negativity increases, but atomic radii decreases from left to right in a period. Clear? Then another point we have discussed about the metallic as well as non-metallic character, right? When you are gaining the electrons, it will be forming the metal ions or cations. So those character is known as the metallic character. So when you are moving from here to here, right, from right to left in a period, metallic character increases or non-metallic character decreases. Clear? So this is the complete summary of the classification of elements and the periodicity in properties. We have discussed by 2 lectures about the periodic properties of elements, right? Ionization enthalpy, electron gain enthalpy, metallic and non-metallic character, atomic radius. So if you are not watching the recorded session, just go and watch the recorded session, then you will get an idea about the periodic properties of the elements. Now in this chapter we have 2 more simple topics to discuss. It is about the diagonal relationship. So after that we will be completing the chapter. We will focus more questions based on the how to predict the position of an element, how to find out the block, period as well as group of an element while getting the atomic number. Okay, do you have any doubt from any part of this chapter? Any part of this particular topic? In the next class, I will be discussing the diagonal relationship, and after completing the diagonal relationship, we will be discussing more questions based on this chapter, previous year questions. Then you will get an idea about that. So those who are not watching the recorded session, just try to watch the recorded session before the next class. So I hope you guys enjoyed the session. If you really like the session, hit the like button, share this session to your friends also, and subscribe to our channel. And if you want to get the session PDF after the classes, you need to join our Infinity Learn 9 and 10 Telegram channel. You will get the session PDF there after all the classes. Okay, Arish, I will try to bring the JEE main questions. So before attending the classes, try to watch all the recorded session for the complete classes. Okay, thank you so much all of you. See you in the next class. Bye bye.